TEK 8.5e. Investigate how evidence of chemical reactions indicate that new substances with different properties are formed. 7.1 Chemical changes. Atoms and molecules are all around us, and so are chemical reactions. How do you know a chemical reaction is occurring? When you make pizza, for example, some of your work involves physical changes and some involves chemical changes. Figure 7.1. In Figure 7.1, it shows this lady who is making pizza from scratch. Here she is preparing the dough. What part of making a pizza involves a physical change? And what part of the process involves a chemical change? Let's read and see if they're going to tell us. You know a chemical reaction has occurred if chemical changes have occurred as well. In this section, you will learn about chemical reactions. Physical versus chemical changes. A review of changes. Matter undergoes chemical changes and physical changes. Recall that a physical change is a change that affects only physical properties of a substance. Examples of physical changes include chopping pizza toppings, like vegetables, into smaller pieces, and melting an ice cube liquid water. Both of these changes involve a change in size, shape, or state of matter. A chemical change is a change in a substance that involves the breaking and reforming of chemical bonds to make one or more different substances. Physical and chemical changes in making pizza. The process of making pizza involves some physical changes like chopping vegetables and some chemical changes. Pizza dough is made of flour, oil, salt, sugar, and yeast. Yeast is a type of fungus. As pizza dough is made, the yeast produces carbon dioxide gas in a process called cellular respiration. The carbon dioxide causes the dough to rise. This gas, the result of chemical change, is responsible for the small holes you see in any kind of bread made with yeast. This action of yeast and heat from an oven causes chemical changes that transform the sticky pizza dough into a tasty crust. You should remember about cellular respiration because we talked about cellular respiration last year during photosynthesis. Energy and changes. Both physical and chemical changes involve energy. For example, you need energy to chop a green pepper into smaller pieces. Energy is also required for a substance to change its state from solid to liquid gas to a gas. Because chemical changes involve breaking and forming bonds, energy is also involved in these changes. Heat or light, forms of energy, are produced or used during a chemical change. The chemical changes in making pizza require the yeast to use and release energy and the heat of an oven to cook the pizza. Okay, so we're going to take a break here and we're going to start taking some notes. So you should be on page 130 in your student journal, and let's go ahead and make our subtitle, which is going to be Chapter 7, Cornell Notes. And since the title of this chapter is Chemical Reactions, and we're going to be doing the entire chapter, I think we should name this page Chemical Reactions. Now, setting up for Cornell Notes, you know that you need to take some lines. So let's try making that. We have across the top. And then we have down the bottom. And since we take modified Cornell Notes, we're not going to do a summary. Okay. We're just taking these notes in order to help us study for tests, exams, quizzes, and so on and so forth. Okay, so the first thing that we read about under chemical reactions were chemical changes. And actually the first thing that we really is noteworthy that I think would be the basic definition of a physical change. So I'm going to write physical change. Here's your book. And it says that a physical change is chopping pizza into smaller pieces, okay, melting ice. So basically a physical change is a change in size, shape, or state of matter. Okay, but it's still the same thing. It just looks a little bit different. So we're going to write that it involves changing size, shape, or state of matter. The next thing that I saw that I think is noteworthy is it talks about chemical changes. And it says that it involves breaking and reforming chemical bonds to make one or more different substances. So that's what we're going to write down as well. So let's write down chemical change. As you know, I love abbreviations, so I'm going to abbreviate because just like you, I do not enjoy notes. Okay? So we're going to say that it's formation of new substances by breaking and reforming chemical bonds. And you should remember that a chemical bond is when atoms share or transfer electrons. That's how bonds are made. Okay. So we are on the next page. What is a chemical reaction? Chemical reaction defined. Just as you learned something about the physical and chemical changes involving in making a pizza, anytime there is a chemical change, a chemical reaction has occurred. A chemical reaction is the process of breaking chemical bonds in one or more substances and then reforming new bonds to create new substances. The process of respiration performed by yeast in making pizza dough is a chemical reaction. This process used to generate heat in a gas stove to bake the pizza is also a chemical reaction, and it is illustrated below. When methane gas, a fuel, and oxygen react, so it's showing you here, methane gas and oxygen react. Here it shows you there's a reaction. The bonds in these molecules are broken to form compounds, carbon dioxide and water. So you've taken these atoms and you basically just redistributed them somewhere else. Evidence of a chemical reaction. When you combine two or more compounds, how do you know whether or not a chemical reaction has occurred? You can't see atoms and molecules actually breaking and forming bonds, but you can observe other events that indicate a chemical reaction. Figure 7.2 illustrates the type of evidence you can expect. For example, if you see a newly formed substance like a gas or a solid, you can suspect a chemical reaction. If a gas is a product in the reaction, you might see bubbles. If a new solid is produced, you might see a powder forming in the reaction mixture so that it turns cloudy. A solid that forms and doesn't dissolve in the reaction mixture is called a precipitate. Similarly, if you see a color change in the reaction mixture, a new substance may have been formed. Finally, evidence of a chemical reaction includes a temperature change. Keep in mind, though, that any heat added to the reaction to get it started is not part of the evidence of a chemical reaction. So here is figure 7.2. These are the different kinds of evidence of a chemical reaction is occurring. We have bubbling right here, which means that a new chemical is being made because we have a gas coming out. Here it's turning cloudy because we have something that is like a solid, so it turns it cloudy. Here we have a color change. Not all color changes are chemical changes because Kool-Aid's not a chemical change, but some are. And then temperature change, when energy is released or absorbed. And remember last year we called that endothermic and exothermic. Right, so now I'm going to stop and we're going to take some more notes. Our next key word should be chemical reaction. Pretty much because that's what we were talking about this page. Chemical reaction, what is it? It's the process of breaking chemical bonds into substances and forming new bonds that make new substances. And I think the next one should be evidence of chemical reaction. And what are the evidence of a chemical reaction? Well, it says that they are bubbling, meaning it's making this gas. We have cloudy, new, solid. We have color change, which is a new substance. And then the last one is temperature change. Okay. Energy released or absorbed. And we're going to write precipitate down here. That's a solid that doesn't dissolve. And we're going to read the next page now. Reactants and products. Parts of a chemical reaction. You can think of a chemical reaction as a kind of recipe. A recipe calls for specific amounts of ingredients to make a food, like a cake. The starting ingredients for a chemical reaction are called the reactants. The resulting substances formed in a chemical reaction are called the products. A product is a compound that results from new chemical bonds forming when a chemical reaction occurs. Reactants are chemically changed to form products. On the previous page, you saw a reaction involving methane and oxygen. In the diagram below, that reaction is presented again so that you can see what happens when reactants are chemically changed to become products. In the reaction, methane, a natural gas, which is right here, is burned or combusted. Some energy is added to get the reaction started. Once this happens, a carbon atom from the methane molecule reacts with the oxygen that's in the air to form a carbon dioxide. Okay. Since single oxygen atoms and hydrogen atoms also combine to form water. This reaction is particularly useful in making gas stoves work because a great deal of heat is released by this reaction. States of matter in a chemical reaction in making pizza. You can tell that a reactant in the reaction below are gases because of the symbol G, listed next to the molecules, figure 7.3. That's this figure. And it shows you here, methane gas is a gas, oxygen is a gas, carbon dioxide is a gas, and this water here, this water is also a gas. You can tell that the reaction and the reaction below are gases because of the symbol G listed next to the molecules. In the same way, you can see that the products are gases, carbon dioxide gas and water vapor. In the next section, you will learn more about the ways that chemical reactions are written and the symbols that are used. Up here is your vocabulary, or some of them. These symbols tell you that S means that it's solid, L means that it's liquid, G means that it's gas, and AQ means that it is dissolved in water. We're going to go and take some notes. Our next keyword is going to be reactants and products. Okay. A reactant is what you start with. It's to the left of the arrow. I'm going to take this off. The arrow means that there's a reaction. And the product is what has been made. It's to the right of the arrow. That's it for 7.1. We're going to continue on to 7.2.